Assalamu alaikum. I am Hassaan TUFAIL. Today we are going to design BCD to access-3 converter. As it is clear by the name, BCD digit can be converted to its corresponding access-3 code by simply adding 3 to it, i.e. we will add 001 in each group. First of all, we have the truth table. In the truth table, A, B, C and D are the bits representing the binary numbers, where D is the least significant bit and A is the most significant bit. Similarly, W, X, Y, and Z represent bits of the access-3 code, where Z is the least significant bit, W represents the most significant bit. After the truth table, we implemented the rudimentary method. In this method, we make combination. We compare the output and input. We make pairs of 2 at the output and compare with any one of the input and make relation. We always divide in 2 bits. From the truth table, we can see that if we make pair of 2, 1, 0 and compare with D, we see that Z is just the complement of D. Similarly, we will compare W with D, X with D and Y with D. We cannot compare Y with C or Y with B. This is because we will compare all the outputs with the same input. We will see that first pair of Y is the complement of D. Similarly, second pair of Y is similar to D. Third pair of Y is again complement of D. Fourth pair of Y is again simple D, and fifth pair of Y is the complement of D. Similarly, we will compare all the outputs with the D and get these 5 equations. In these equations, we will implement our circuit on Proteus. And here we have used 3 multiplexers. A multiplexer can be considered as multiple input and single output. This means that it doesn't matter how many number of inputs there will be only one output. We will start simulation table. So B, C and D all are 0. From the truth table we can see that W, X both are 0 and Y, Z are 1. This can be seen here in the circuit. Similarly, when A, B, C and 0 and D is 1, we see from the truth table that only X blinks. So here only X is 1. A is 1 and D is 1. At the output, only W and X are 1s. You can see W and X are 1 and Y and Z are 0. We can verify all the equations by simply changing these values. So this is a binary coded decimal to access-3 converter. Now, using the same concept of multiplexers, we have created light system for cars. Here, this is for the left side and this is for the right side. Here, left turn is the most significant bit and emergency is the least significant bit. On the right side, right turn is the most significant bit and emergency is the least significant bit. Now, let's see its operation. Emergency, and we click braking. Here, braking overcomes the emergency and the light stops. Similarly, if we click the left turn, as the left turn is the most significant bit, so it starts blinking again. So it shows that it is overcoming both of them. The same phenomena is occurring for the right side. Here, right turn is overcoming the other two. When we apply the emergency, it blinks, and we apply the brake. The braking overcomes the emergency, and again when we click the right turn overcomes both of them. This is how light system for car works.